Hey everyone, let's continue analyze problems in homework 2 so that you will be ready to succeed in your computer architecture exam. So, you may think that we're going to cover caches. Not. Professor told that this kind of cache problem, particularly this one, maybe there will be another one related to cache, but this problem won't be in final, so we're gonna skip this one, okay? So anyway, if you wanna kind of understand it, you can read the lecture notes, and also the clear explanation is given. So I also myself didn't understand it so well, and plus it won't be in final, so let's skip it. The question number 5 will be in the final, okay? And the question number 5 is the most easiest one. 21 points. Oh. So what you do here, you don't need to understand each number, what does it represent, and so on. If you ask it SPI-A, what you do is you concentrate on processor A, and you multiply this SPI value to the frequency, okay? Frequency of occurrence, this one. So you don't multiply 3 to 40, you multiply to 0.4. I mean, firstly, you divide this percentages, this frequency by 100. So if I do it like that, what it will be? It's gonna be 0.4, 0.4, 0.25, 0.25, 0.1. Okay, so this is the frequency of the occurrence, and then you do what? You just multiply these two columns, okay? These two columns, value, and then you just add the result of each multiplication. For example, as you can see, this is nothing but this one, right? Okay, this is the first row, this is a multiplication of second row, third, and fourth. 8, this is 8, and 0.1, simple, right? You get the value of SPI. So the same thing you do in processor B. First we convert them into the appropriate value, but by appropriate value I mean that you have to divide this percentage value by 100. So it's gonna be 0.15, 0.15, 0.1, 0.1, again 0.1, and 2 times 0.2, 0.2. You multiply this SPI value to corresponding frequencies, and then finally you add them and you get 2 here. Okay, you can see it. Very simple. So now what you are asked to find, what are the MIPS of A and B. So for this you have to divide given clock frequency, okay? I mean, for both processors, this is processor A, processor B, initially you will be given the clock frequency. For A, it is 600 megahertz, I guess. This is, for B, it's 500. So in order to find MIPS of A and B, this is a formula. MIPS A, let's say, clock frequency CF, okay? You are given this one and this one, divided to CPI, okay? Let's delete this A, this general formula. So as CPI you get from the previous step, part A, right? For example, you're given that the clock frequency of A is 600 megahertz, I don't know, mega or milli, not milli, mega. So you take the 600 and divide it by CPI of A, which is 3, so 600 divided by 3 is 2. And the same you do for processor B. You're given that it is clock frequency is 500 and SPI B is 2, so you put it here, so your result is 250. So finally you have to find out total time spent on processor A and B, and you have to choose which processor you're going to choose. You have to do kind of choose one processor based on the trade-offs. So your trade-off is nothing but the time. So you have to calculate the total time on processor. Okay, you will be given the total number of the instruction. So let's say it's n. You multiply this n to SPI, okay, SPI, and then you divide it to the MIPS, okay, to the MIPS. And you know your MIPS is gonna be in hertz, but it may be in megahertz. If it's megahertz, you multiplied it to 10 to the power 6, right? I mean, hertz, if it's in hertz, just put MIPS without this one. But if it's in megahertz, then you have to also multiply it to the 10 to the power 6. Take it in mind, okay? In this particular case, it is in megahertz, so that's why I write 10 to the power 6, okay? Pretty simple. This is gonna be total time spent. Of course, if it's simple, there should be some tricky parts too, and here it is. It is written in the question that, yeah, the total number of executed instructions on processor B is 50% more than processor A to perform your experiment, in your experiment. So you are given that the total number of instructions for your experiment is 1 million. So this is n, but you're given, you're set. I mean, for you it's given that also in the question already that processor B performs 50% more instructions than processor A. So this 1 million is for processor A. This is an A. So what's gonna be an B? It is 50% more than NA. So NA is what? 1 million. What is the 50% of the NA 1 million? It is 500,000. So if it's 50% more, that means you have to add to NA plus 50% of NA, which is what? NA is 1 million, 50% of NA is 500,000, yeah. So finally, you have 1.5 million, okay? 1,500,000 instructions. So that's why in the case of this N for total time of B, you took the number of instructions, not 1 million, as in the case of processor A, but 1,500,000. Okay, I guess this was enough. So this is very simple, and yeah, I explained everything from the step. So if you confused a little bit, please revise the video or ask your question in the comments. Thank you for your attention. This was the end of the computer architecture series of tutorials, and I wish you really good luck. Get A+.